Okay, so in Unit 3, we're going to be talking about covalent bonding, and we're going to start off by learning how to draw some Bohr models and then how to identify the number of valence electrons that different elements have. Valence electrons are going to be really important for us. Those are the electrons that are actually going to do the bonding. So in order to figure out how elements are going to bond covalently, we first need to be able to identify valence electron numbers. So here, when we're drawing a Bohr model, there are some rules with regard to where we're placing those electrons. So we first need to determine the total number of electrons that the element has. And then we're going to start placing those electrons in orbits or energy levels around the nucleus in a specific pattern or using specific rules. So on our first orbital, we can only place 2 electrons. So my first 2 electrons are always going to be placed along that first orbital. For my second orbital, that is always going to have 8 electrons. So you can see here, my next 8 electrons are placed in my second orbital. When I draw these, I like to pair them up, but you don't necessarily have to do that as long as there are 8, or as long as you place the next 8 in that next orbital. And then the next 8 electrons will be placed in the third orbital. Notice how in my diagram on the right, there's only 1 electron in that last orbital. That's because there was only 1 electron left to place. So notice here, in this element, there are 11 protons. That means that this element is, if I look at my periodic table, sodium. So this is sodium. I know this because it has 11 protons and sodium has atomic number 11. It has a number of neutrons of 12. That means my mass number, if I add those 2 things up, is 23. If it has 11 protons and it's a neutral atom, that also means that it should have 11 electrons. So let's count. 1, 2 in the first orbital, 3, 4, 5, 6, 7, 8, 9, 10 in the second orbital, and then that 11th electron is bumped out into that third orbital. So let's go ahead and do an example here with chlorine 35. So chlorine with a mass number of 35. So I'm going to start by going ahead, I'm going to draw in my nucleus here. So here's my nucleus, and I need to determine the number of protons and the number of neutrons that should be in that nucleus. So for chlorine, if I look at the periodic table, it's atomic number 17. So my number of protons is going to be 17. I've told you using isotopic notation that this chlorine has a mass number of 35. So I'm going to go ahead and take my mass number of 35 minus my 17 protons, and that gives me 18 neutrons. It doesn't look like this is a charged particle, so when I draw in my electrons, I know that the number of electrons has to be equal to the number of protons, which is going to be 17. So I'm going to start drawing my orbitals here. So here's my first orbital, and on that first orbital I can place 2 electrons. So here's my first 2 electrons, 1, 2. Now I need to bump to the second orbital. On my second orbital, I can place 8. So my next 8 electrons will go in here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I have 10 total electrons placed. And now I need a third orbital because I need 17. I know I have 7 electrons remaining. So I'm going to go ahead and place those remaining 7, 5, 6, 7 electrons on that third orbital. So there is my Bohr model for chlorine with a mass of 35. Okay, so you guys are going to have to be able to identify protons and neutrons, put them in the nucleus, and then draw the electrons on the appropriate orbitals around the outside of the nucleus. So now let's just take a look at some Bohr models that I've already drawn out and identify whether they're correct or incorrect. So for this Bohr model, this has number of protons is 14. So I'm going to go ahead and find that element. So this is silicon right here. So silicon has the atomic number 14, so 14 protons. There are 14 neutrons, so the mass number for this one must be 28. And if there are 14 protons, there should also be 14 electrons, and I need to make sure they're placed appropriately. So let's see. 1, 2 electrons are in the first orbital, so far so good. There's 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second orbital. So far we have 10, and then in my third orbital I have 1, 2, 3, 4 electrons for a total of 14. So this one looks like it's correct. So let's move on to this next example here. So here I have number of protons is 16, so I'm looking at the element sulfur. There are 16 neutrons as well, so the mass number must be 32. So if there are 16 protons, there must also be 16 electrons. So I'm counting here 1, 2 on the first orbital, and then 3, 4, 5, 6, 7, 8. 6 of those are on the second orbital for 8 total. Because there are only 8 electrons and there should be 16 electrons, this is incorrect. So this should be a full orbital, and then there should be a third orbital drawn here that has those 6 electrons. So we're missing 8 electrons in this example. Okay. So we've talked about valence electrons before, and we know that valence electrons are the electrons in the outer orbital or that outer energy level. So if I look here in these diagrams, here is boron. Boron, if we draw out the Bohr model, has 1, 2, 3 valence electrons. Silicon, if we draw out the Bohr model, has 1, 2, 3, 4 valence electrons. Antimony, if we do the same thing, has 1, 2, 3, 4, 5 valence electrons. So one way that we can determine the number of valence electrons is by drawing a complete Bohr model. Unfortunately, that for some elements, so if we look at antimony here, that takes forever. So there is a shortcut on the periodic table for us. The super smart scientists who organized the periodic table organized it so that each group or each family in the periodic table has the same number of valence electrons. So if we go down the columns, you'll notice that every element in that column will have the same number of valence electrons, and they're ordered from left to right. So if we look at the first column on the periodic table, all of the elements in that first column have 1 valence electron. If we look at the second column, all of the elements in that column have 2 valence electrons. Notice here that in the center section of my periodic table, so my transition metals, there are no numbers in here. So we are going to skip over the transition metals. They have extra orbitals. So when we're identifying valence electrons, transition metals can get weird sometimes. So we kind of skip over this transition metal block in the center. We move to the next column. So 3 valence electrons in my third column when we skip over my transition metals. 4 in my fourth, 5 in my fifth, 6 in my sixth, 7 in my seventh. This 8th column gets a little bit funny because we have helium up here on the top right hand corner. Notice how this one, helium is marked with only 2 valence electrons. The reason for that is because helium only has 2 electrons total. So it has that first orbital full already. So really these are elements that have a full outer energy level or a full outer orbital. That's why they're super stable and they don't really bond with stuff. So this 8th column has 8 valence electrons with the exception of helium, which only has 2, because helium only has 2 valence electrons, but because that first orbital only can hold 2 valence electrons, that also means that helium has a full orbital. So that's just kind of an easier, faster way to identify those valence electron numbers for each of our elements. So you guys are going to have to be able to do this really quickly. So just looking at which column on the periodic table is going to be a really fast and easy way for us to do this.